Hello, today we are going to discuss a numerical of NCERT textbook, page number 55, volume 1, and example 2.1. Have you got it? Of example 2.1. Calculate potential at a point P due to a charge of 4 into 10 to the power minus 7 coulomb located 9 centimeter away. Calculate the potential at a point P due to a charge of 4 into 10 to the power minus 7 coulomb located 9 centimeter away. And second part, hence obtain the work done in bringing a charge of 2 into 10 to the power minus 9 coulomb from infinity to the point P. Here is another part. Does the answer depend on the path along which the charge is brought? In the second question B, obtain the work done in bringing a charge of 2 into 10 to the power minus 9 coulomb from infinity to the point P. And here is another part. Does the answer depend on the path along which the charge is brought? This numerical based on the topic potential at a point due to a point charge which is r distance away. So this is the direction of electric field. This is infinity. Can you remember the figure? This figure is already discussed, and value of point charge is 4 into 10 to the power minus 7 coulomb. R is 9 centimeter. So if I convert it to SI unit, 9 into 10 to the power minus 2 meter. What is the expression of potential at a point due to a point charge? The expression is this: V is 1 by 4 pi epsilon 0 Q by R. Potential at a point r distance away from the point charge q, small q, is given as V is 1 by 4 pi epsilon 0 Q by R. Can you remember the value of 1 by 4 pi epsilon 0? Can you remember this value? It is 9 into 10 to the power 9. What is the value of Q? 4 into 10 to the power minus 7. What is the value of R? 9 into 10 to the power minus 2. Therefore, this 9 and this 9 get cancelled. We get 4 into 10 to the power 9 minus 7. It is the numerator, so 10 to the power minus 7. In the denominator, 10 to the power minus 2. If it go to the numerator, it is plus 2. Now it is 4 into 9 plus 2. 9 plus 2 is 11 minus 7. So it is 10 to the power 4 volt. So potential at a point P 9 centimeter away, from the point charge of 4 into 10 to the power minus 7 coulomb, 4 into 10 to the power minus 7 coulomb is found to be 4 into 10 to the power 4 volt. 4 into 10 to the power 4 volt. Okay? The electrostatic potential at a point P, which is 9 centimeter away from a point charge of 4 into 10 to the power minus 7 coulomb, is 4 into 10 to the power 4 volt. 4 into 10 to the power 4 volt. So this is the part A. This is the part A of the questions. Now we try to discuss the question B of example 2.1. Question B of example 2.1. So what is potential at a point P? Potential at a point P is 4 into 10 to the power 4 volt. What is in the second part? In the question B, they say that hence obtain the work done in bringing a charge of 2 into 10 to the power minus 9 coulomb from infinity to the point P. Does the answer depend on the path along which the charge is brought? Have you got it? Question number B. Hence obtain the work done in bringing a charge of 2 into 10 to the power minus 9 coulomb from infinity to the point P. Does the answer depend on the path along which the charge is brought? Now, a charge Q, a test charge Q is brought. What is the value of test charge? What is the value of test charge? The value of test charge is 2 into 10 to the power minus 9 coulomb. 2 into 10 to the power minus 9 coulomb. Therefore, work done necessary to bring a work done necessary to bring a test charge capital Q from infinity to the point P. W is equal to Q into V. What is Q? Q is 2 into 10 to the power minus 9. What is V? What is potential at the point P? Potential at the point P is 4 into 10 to the power 4 into 10 to the power 4. 4 into 10 to the power 4. So 2 into 4 is equal to 8. 8 into 10 to the power minus 5 joule. So necessary work done to move the charge. 2 into 10 to the power minus 9 coulomb. 2 into 10 to the power minus 9 coulomb from infinity to the point P is found to be 8 into 10 to the power minus 5. 8 into 10 to the power minus 5. 8 into 10 to the power minus 5. There is another part in the question. Does the work done, have you got it? Have you got it? Does the answer depend on the path? Does the answer depend on the path along which the charge is brought? Our answer is no. That means amount of work done to bring the charge 2 into 10 to the power minus 9 coulomb from infinity to the point P is independent of the path traveled by the object. It only depends on initial and final point. It is because electric field is a conservative field and work done in conservative field is path independent. It only depends on initial and final point. Can you remember this expression? dV is equal to E dot dr. This is already discussed in the topic where we discussed electric field intensity as negative gradient of potential gradient. Where we discussed electric field intensity as negative potential gradient, or in the topic relation between electric field intensity and potential difference. So this is the direction of electric field. This is the direction of electric field. Say this is the direction of r vector. R vector means displacement vector. In the question they ask, does the work done depends on the path traveled by the object? We have to prove it. Say, I want to displace the charge in this direction. I want to displace the charge in this direction. I displace the charge dr in this direction, making an angle theta. Then this dr can be resolved into two components. One is dr cos of theta. This is along the r. This is along r. This is along r vector. R vector means displacement vector, and other is perpendicular to r vector. This is perpendicular to. This is perpendicular to r vector. So in order to prove that, the work done is independent of the path traveled by the object, we assume that, so this is the direction of displacement. I displace the charge in this direction, making an angle theta with the original direction of r vector, with the original direction of displacement vector. This is the r cap. So therefore, this dr can be resolved into two components. One is dr cos of theta along r, and one is dr sine of theta, and one is dr sine of theta perpendicular to r. One is dr cos of theta along r, and one is dr sine theta perpendicular to r. Now, what is the angle between? So this is the direction of E vector also. This is the direction of E vector also. For perpendicular component, dr sine theta, angle between E vector and displacement theta is equal to 90 degree. So what is the value of cos 90? 0. Therefore, work done along the perpendicular displacement, is equal to 0. That means if you move the charge in this part also, along this direction, then this can be resolved into two components, one along electric field and one perpendicular to electric field. Since this component makes an angle of 90 degree with the direction of E or direction of r cap. Therefore, work done along the perpendicular component is 0 because cos 90 is equal to 0. Hence, work done in displacing the charge is independent of the path traveled by the charge. Therefore, in the book, they already given the answer. Have you got it? No. Work done will be path independent. What is the reason? Any arbitrary infinitesimal path can be resolved into two perpendicular components or two perpendicular displacement, one along r and another perpendicular to r. Work done corresponding to latter will be 0 latter means work done along the perpendicular component will be 0 and hence our answer is no. Explanation is given. You may write this answer. You may write this answer. So our answer is no. That means hence the answer means work done does not depend on the path. ইয়াতে বুকখনত যে লিখিছে ইনফাইনাইট এচিমেল, এই স্মল ডিসপ্লেসমেন্টটোকে ইনফাইনাইট এচিমেল ডিসপ্লেসমেন্ট বুলি কয়। এটোকে ইনফাইনাইট এচিমেল ডিসপ্লেসমেন্ট বুলি কয়। ইজ ইট ক্লিয়াৰ?